Hi everyone. In this video, we're going to introduce the term enthalpy. Enthalpy is defined as the heat exchanged with the system under constant pressure. And we represent enthalpy with a delta H, and that's equal to Q under constant pressure. So we'll say Q sub P. If we take enthalpy and what we already know about changes in internal energy, we can see how enthalpy relates to internal energy. So delta E is equal to Q plus W. If our chemical or physical process is occurring under constant pressure, we can rewrite our delta E equation to include QP plus the work done on or by the system. Now, if we're under constant pressure, the work done is almost always pressure volume work. That is, changes in the volume of my system. And work is equal to negative P delta V. That is the pressure of the surroundings and then the change in volume of the system. If we substitute our delta H for QP, we can get delta E in terms of enthalpy. And I'll go ahead and simplify this portion of the equation. So now we see that delta E is equal to delta H minus P delta V. Now why is this useful? Well, enthalpy is relatively easy to measure, and we'll actually learn about that in later lessons when we discuss calorimetry. And typically, if we're looking at reactions of liquids or solids, the change in volume here is going to be negligible, and we can say that delta E for those processes where the volume change is very small or essentially zero, that the energy is equal to the change in enthalpy. In fact, enthalpy is so commonly used that we have special terms to describe it with respect to a system. If a system loses heat, or heat is exiting the system, we call that an exothermic process. The opposite scenario, where heat is entering a system, we call that an endothermic process. I like to use the prefixes X and N as ways to keep track of which is which. So heat exiting is exothermic, and heat entering is endothermic. And these terms will be important for us as we move forward. The next time you see enthalpy, just think heat. It is a good approximation of the internal energy changes of a system during a chemical or physical process. Delta H, like delta E, is also a state function, so it's independent of the path that we take to get there. Be sure to learn your definitions of exothermic and endothermic and how the sign of delta H correlates to those terms. Thanks for watching.